Next example, I'd like to find f prime of 2. That's the derivative of f evaluated at x equals 2 for the function f of x is equal to the square root of 4x plus 1. Now, first thing I'd like to do here is find f of 2, since that's used for both of the derivative formulas. That's going to be the square root of 4 times 2 plus 1. By my calculation, that's the square root of 9. That'll be equal to 3. So I'm going to set up and evaluate both forms of what the derivative can look like. So f prime of 2 is going to look like the limit. My goodness, there's a cat hair on me. Big shocker. There's always cat hairs all over this house. So our limit as x approaches 2 of f of x minus f of 2 all over x minus 2, which is going to look like the following. The limit as x approaches 2 of the square root of 4x plus 1 minus f of 2, which we calculated to be 3, all over x minus 2. The alternate form of the derivative is the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Replacing all of the x's with a 2 plus h, this would be the limit as h approaches 0 of the square root of 4 times the quantity 2 plus h plus 1 minus f of 2, which is 3, all over h. The strategy for both of these is going to be relatively the same. In both of these cases, we have an indeterminate form. You can verify that both of these limits take the form 0 over 0, but that's pretty typical for the definition of a derivative. They also both involve radicals, so we're going to be making use of the strategy where we use the conjugate of the radical. We'll be multiplying top and bottom of our fraction by the conjugate of the numerator. We spend years in algebra classes telling you how to rationalize a denominator. Then you show up here in calculus and we're all like, we're going to rationalize the numerator now. So your numerator takes the form a minus b times a plus b. That's going to result in a squared minus b squared up top. So that'll be the square root of 4x plus 1, quantity squared, minus 3 squared. Your denominator remains as is. There's no reason to FOIL since we're going to want to have it factored eventually anyway. Continuing to simplify that numerator, this will be the limit as x approaches 2 of 4x plus 1. Radical cancels the square root, or excuse me, the square cancels the radical, minus 3 squared, which my calculator tells me is 9, over x minus 2 times the square root of 4x plus 1 plus 3. Combining like terms in that numerator, we get the limit as x approaches 2 of 4x minus 8 over x minus 2 times the square root of 4x plus 1 plus 3. Good news here is we have a greatest common factor in the numerator that can be pulled out, and we do so. Factoring out a 4 leaves us with a factor of x minus 2, and that's just good news. It is good news because we're going to eliminate the thing that was causing the 0 in the denominator with the thing that was causing a 0 in the numerator. This leaves us with the limit as x approaches 2 of 4 in the numerator, and in our denominator we have square root of 4x plus 1 plus 3. You can now use the direct substitution property to get the limit as x approaches 2 of 4 over the square root of, oh, I used the direct substitution property, I don't write limit anymore. Four over the square root of 4 times 2 plus 1 plus 3. Inside the radical, that's 8 plus 1, that's 9. Square root of 9 is 3. 3 plus 3 is 6. And your fraction reduces down to 2/3. Good stuff. Now let's take a look at the alternate method. Up at the top of the page. We're a little jammed in here. Hopefully we'll be able to fix that before too long. So I'm going to do 2 steps of algebra in 1 step. I am going to distribute the 4 and combine the 1. So 4 times 2 is 8, plus 1 is 9. And distributing the 4 inside the parentheses, we'll get a plus 4h minus 3 all over h. Same strategy as what we did before. We are going to borrow for that fraction bar a little bit, multiply by the conjugate of the radical expression in the numerator. That's the square root of 9 plus 4h plus 3. So once again, we're multiplying something of the form a minus b times something of the form a plus b. That is going to cause something of the form a squared minus b squared. So the square root of 9 plus 4h squared minus 3 squared all over h times the square root of 9 plus 4h plus 3. The algebra that you're going to see from here mirrors the algebra that was just done over on the left side. So starting from this step, it's going to look relatively the same as we go down. Square cancels the square root, 9 plus 4h. Square the 3. Leave the denominator as is. Combine like terms, 9 minus 9 leaves us with 4h in the numerator. And h times our nice big radical expression after that. Now, like we saw over here, that means that we can cancel out a factor of h with h, leaving us with the limit as h approaches 0 of 4 over the square root of 9 plus 4h plus 3. At this point, we're good to use the direct substitution property due to the fact that we have canceled out the thing that was causing the 0 in the numerator and the denominator, leaving us with, do not write limit after we use the direct substitution property. This is 4 over the square root of, let's see, 9 plus 4 times 0, that's just 9. Then we'll see the exact same arithmetic that we saw over on the left side of the page, leaving us with a final answer of 2/3. To reiterate for a third time, it is not necessary to do both of these processes. It's okay to simply use one or the other. I want to demonstrate both so that you have something to go on, so that you can start making a decision about which one you prefer as you start working through these problems. Yay.